Okay, now we're at question 4, and question 4 wants us to prove that opposite sides of a parallelogram are equal. So this proof starts with a construction. So we need to construct a diagonal here. So meaning that, okay, for proof we start with construction. This is 4.1, and in our construction we are going to draw we've drawn diagonal AC, and then now what are we required to prove here? We are required to prove that AB is equal to DC, and also we are required to prove that AD is equal to BC. So that's what we are required to prove. Let's see how we can do it. Because we've drawn a diagram here, we've created two angles at angle A. So this will be A1, and then this will be A2, and then also we've created C1 and C2 over here. But now because we have alternating angles here, you'll get that the angle A1 is equal to the angle C2, because what's this, A1 and C2 alternate. So these are alternating angles, so you just write it as your reason, alternating angles, and they are between the two parallel lines. So the parallel lines that we've just used here, A1 being parallel to A1 alternating with C2, is that AB is parallel to DC. So AB is parallel to DC, and this one was given, right? And then another thing is that the angle C or A2 is equal to this angle here, which is C1. So A2 is equal to C1. So the angle A2 is equal to C1. But now we've used different alternating angles now. We've used different parallel sides now. So these are alternating angles, and they are between the two parallel lines, which is AD is parallel to BC. This is what we are given, right? Then now in the two triangles, so we have triangle 1 and triangle 2, and in the two triangles you'll see that AC is a common side. So AC in triangle 1 is equal to AC in triangle 2 because it's common. This is common. Therefore, what we can say now, the triangle A, or let's just say the triangle ADC. So the triangle ADC is now congruent to the triangle ABC. So it's congruent to the triangle ABC, and the reason for the congruency is that it's angle side angle. So we have an angle, we have a side in between two angles, so that is those two are congruent triangle. Therefore, in congruent triangles we have also equal sides, so meaning that now the side AB is equal to the side DC, and also we have AD being, the side AB is equal to DC, and the side AD is equal to BC. So very simple. And then we've just proven that opposite sides of a parallelogram are equal. Then we go to the next question, 4.2. 4.2, we are given that JM is parallel KL, JK is equal to O or JO, ON is equal to KL, and then the angle J is 2x, M is 52, and L is x, and then we need to answer the questions that follow. The question asks, what type of a quadrilateral is ONK? Let's look at O. Starts from O to N to K, and or to L, then to K. And if you can see that in the shape there, you'll see that O. Let me just fix this. ON is equal to KL, and ON is also parallel to KL. So what is this? This is what? This is a parallelogram. Why the parallelogram? Because we have one so we have one pair of opposite sides being equal and parallel. This is for 4.2.1. Then now we go to 4.2.2. It says calculate with reason the value of x. So we need to find the value of x, and immediately I can see that we have a parallelogram, right? So meaning that also this side is parallel to this side. So meaning that if I can have this angle here, which is an exterior angle, meaning it's equal to the sum of the interior opposite, which is x plus 52, this will also be what? X plus 52. And then now, because we have equal sides, angles opposite equal sides will make this x plus 52 also. Then now sum of interior angles of a triangle add up to 180, and then I can solve for x. But how do I write this down? First of all, n1 is equal to x plus 52. So it's x plus 52, and it's because this is the exterior angle of a triangle, right? Then now, because we have proven that ONLK is a parallelogram, then it would mean that KO is parallel to NL, meaning that now we have O1 equal to x plus 52 because of what? Of corresponding angles. Corresponding angles, and between which parallel lines OK is parallel to NL. Then now, because O or JO is equal to JK or KJ, then it means that now K1 is equal to x plus 52 because of angles opposite equal sides. So that's angles opposite equal sides. Therefore, what I can do, I can take this 2x plus x plus 52, the first one, plus another x plus 52, x plus 52 is equal to 180. This is the sum of angles in a triangle. So now I have how many x? I have 2x and another 2x, and 52 and another 52, so meaning that now I'll have 4x plus 104 is equal to 180. Then now 4x is equal to 180 minus 104 is 76. Then now x, then we divide by 4, divide by 4, then x is equal to 76 divided by 4 is 19. So that is very simple there. Let's see the next question. The next question is question 5, and for 5.1 we have that we need to write down the length of OQ, but let's read the information. PQRS is a kite such that the diagonal intersects at O. So we know that in kite, diagonals intersect at 90 degrees, and also the larger diagonal bisects the smaller one. That's what we know about the kite. And then now it says write down the length of OQ, and we know if now the larger diagonal bisects the smaller one, it would mean that now OQ is equal to 2 centimeters because it's equal to OS. Very simple there. 5.2. Write down with reason the size of POQ. So from P to O to Q. So this angle over here. And in a kite, we know that so this is POQ, right? Oh yes, it's not this angle here. It's from P to O to Q. We know this is a right angle. So POQ is equal to 90 degrees. And why? It's because diagonals of a kite meet at 90 degrees. So very simple there. 5.3, we have write down the size of QPS. So from Q to P to S. So this big here, the big angle here. So so what we can do, we can say that the angle OPS is equal to OPQ. So OPS, so the angle OPS is equal to, so from O to P to S is equal to OPQ. And why? It's because the diagonal of a kite bisects this angle here. So the diagonal of a kite bisects the angle here. So your reason is the diagonal of a kite. Then now it would mean that now OPS is 20 degrees. So the entire angle, so this angle here is 20 degrees. So the entire angle QPS is equal to 20 plus 20, which is equal to 40 degrees. So very simple there. Let's look at the mark allocation for the two questions. First of all, we start with our proofs, which is 4.1, and for 4.1 it's for 5 marks. So you do get a mark for your construction here. There's your construction, that is 1 mark. And then you get a mark for alternating angles. You get a mark for alternating angles again. And then you get another mark for proving congruency. And that's how many marks. And then you get a mark for the common side. And then is a total of 5 marks. Then for 4.2, you get a mark for the type of quadrilateral the reason, that is 2 marks. And then 4.2.2, you get a mark for exterior angle. You get a mark for you get a mark for 90 what's this, sum of angles, and then you get a mark for the answer, which is 4 marks. Then we go to 5.1, 1 mark. Then 5.2, you get a mark for the statement and the reason, that is 2 marks. And then the last question, you get a mark for OPS, and then another mark for OPS, and then another mark for, wait, the first one is O, so I made a mistake here. It's OPS is equal to OPQ, so this is QPS, yes. So OPS, you get a mark for OPS, and then you get a mark for QPS, which is also 2 marks. So yeah, that's 5 marks for question 5, and then 11 marks for question 4. Okay, so for question 6, we are given a diagram here, and it says that P is the midpoint of the side WQ, and the triangle WQR, and then V is on WR such that VP is parallel to RQ. So we are going to put parallel lines here, okay. And then PV is produced by its own length 2s, so PV, okay, so that is indicated. And then PW is produced to T, so PW is produced to T, and ST is drawn. Okay, fine. Let's look at the question now. Let me just minimize the ribbon. Let's look at the question. Question 1, it says, why is WV equal to VR? So we need to prove why is WV equal to VR. But we have been told that the line PV is parallel to QR, and we also have a midpoint. So what we know is that for 6.1, WV is equal to VR because we have a line from, or a line through a midpoint parallel to one side. Through midpoint parallel to one side, it makes V the midpoint also. Okay, fine. 6.2, we have proved that. So prove that VWP is congruent to VRS. So we have V, so from V to W to P is congruent to VRS. I think that is very simple to do. Already we have annotations here. So what we can do now, we can say that VP is equal to VS, and this one is given from the information. but we have established that V or WV, yes, WV is equal to VR from midpoint theorem. And also we can say that V1 is equal to V3, and these are vertically opposite angles. So now that the triangle VWP congruent to the triangle VRS, and the reason why is a side angle side. So very simple there. And then the next question is, oh, this is 6.2.1 and 6.2.2 now. 6.2.2 is we must show that SWPR. So we must prove that SWPR is a parallelogram. But already we have proven that if this is a parallelogram, if SWPR is a parallelogram, we've proven this already because we can see that the side VP is equal to VS, and also WV is equal to VR, and these are diagonals of the supposed parallelogram. So meaning therefore SWPR is, oh, let me write it correct, SWPR is a and the reason is that diagonals bisect each other. Very simple there. And then we have 6.2.3. 6.2.3 wants us to prove that PQRS is a parallelogram. So but it's very easy to do. First of all, we know that we are given that WP is equal to PQ, right? So WP is equal to PQ, and you can see it's given here. WP is equal to PQ. And then another thing, we have just proven that WP is equal to SR from the congruency, right? So this is proven that this is equal to, so we can just put ones. So immediately we know that PQ is equal to SR. So let's just say P. Therefore PQ is equal to SR. So we can say PQ is equal to SR. That's the first thing that. So we've just proven that PQ is equal to SR, right? Then now the next information, we can use the fact that we have proven that SWRP, right, is a parallelogram. We've just proven in the previous question, we've just proven that SWRP is a parallelogram. So meaning that this side that is not drawn is parallel to this side, and then this side is parallel to this side. Therefore PQ is also parallel, in fact it's also parallel to SR, because we've proven that SWPR is a parallelogram. So meaning that now And the reason is SWRP or PR is a parallelogram. We've proven that this is a parallelogram, right? And this is proven. Then now we can say that PQRS is a parallelogram because we have what? 1 equal and pair of opposite sides being equal and parallel. Now let's look at the last 6.3. 6.3. It says if it is further given that RSTW, so RSTW, okay, so we are told that if it is further given that this RST, so it's from R to S to T to W. So if it is further given that this is a parallelogram, if show that TQ is 3 times the size of SR, so we must prove that TQ is 3 times the size of SR. Okay, so how do we do that? First of all, we are given that SR is equal to WP, right? So let me just cut a new shape here. Let me just cut a new shape here, because this will need me to go in depth. Okay, so I have this shape. Just put a new shape here. Okay, yeah. Okay, let me just move it a bit. No, it's fine. So what we've proven so far is that this is a parallelogram, so meaning equal and parallel, and then this is also parallel here. Okay, so we need to prove that TQ is 3 times the size of SR. So first of all, we have proven that SR is equal to WP, right? Okay, so, and this is from the congruence, right? So SR is equal to WP. This is proven. So yes, proven. Okay, SR is equal to WP, and then we've proven that SR also is equal to PQ. We've proven that SR is equal to PQ, and it's because of the parallelogram. So this is also proven. Fine. Then now we are saying Guti, this STW STW is a parallelogram. So meaning Guti, this side and this side are equal, and this side and this side are equal, and they are also parallel. They are also parallel. So meaning Guti, SR, in fact, is also equal to TW. because because in the question it just says that RSTW is a parallelogram. Sides of a parallelogram are equal. So now if you look at what I'm going to note here is that this side is equal to SR and this side is equal to SR, and also this side is equal to SR. So now what does that mean? This means that the whole thing here is TQ, right? And how many SRs do you see in TQ? There's 3 of them. So meaning therefore we can say that TQ is equal to TW plus WP plus PQ, and all of these are equal to SR plus this is equal to SR, and the other one is also equal to SR. So meaning that TQ is equal to 3SR. So very simple there, and we've reached the end of our question paper. Let's look at our final mark allocation as we close. So 6.1 is 1 mark. Oh, yes, 1 mark, and then you get a mark for the reason here. And then 6.2 is 3 marks. You get a mark for the statement and reason here. You get a mark for the statement and reason here. You get a mark for statement and reason, and then that is 3 marks. 6.2.2 was out of 2 marks, so you get a mark for both of these values, and then you get a mark for the reason why it is a parallelogram. Then for 6.2.3, this was a total of 4 marks, so you get a mark for WP is equal to PQ, and you get another mark for WP is equal to SR, and then you get a mark for proving that SR is parallel to PQ, and then you get a mark for the conclusion, which is 4 marks here. And then the last question, 6.3. 6.3 was a total of 3 marks, so you get a mark for SR being equal to PQ, you get a mark for SR being equal to TW, you get a mark for the expression here, and that is a total of 3 marks, and which is 13. And we've reached the end of our question paper. I hope you enjoyed the session, and I hope you'll use this information efficiently. I'll see you on the next video.